Hello everyone. Thank you for joining me today. Today, I want to take you on a journey into one of the most exciting frontiers of clean energy, green hydrogen production, and in particular, how it's achieved using proton exchange membrane electrolyzers. Green hydrogen is not just a buzzword. It's becoming one of the pivotal solutions for achieving global decarbonization goals and building a sustainable future for generations to come. So first, why green hydrogen? Green hydrogen is produced through water electrolysis, splitting water molecules into hydrogen and oxygen using electricity that's sourced from renewable energy like wind, solar, or hydropower. This means no carbon emissions, unlike conventional hydrogen production from fossil fuels. Among the technologies that make this possible, proton exchange membrane electrolyzers stand out. Because they offer high efficiency, fast response times, and a compact, modular design. These qualities make them ideal for pairing with renewable energy, which, as we know, can be intermittent depending on sunshine or wind conditions. Now, let's dive deeper into the actual electrolyzer systems. Most green hydrogen production units today are containerized. Imagine shipping containers, but instead of cargo, they house all the high-tech equipment needed to produce clean hydrogen. Hydrogen is, of course, a highly flammable gas. And under the wrong circumstances, it can even be explosive. That's why proton exchange electrolyzers are designed with a host of automatic safety systems. For instance, they have forced air ventilation systems, bringing in fresh air from the outside and filtering out dust and dirt. If the ventilation fails, the whole system automatically shuts down to prevent any risk. The layout inside these containers is usually split into three main sections. 1. The control room, containing all the switchgear, programmable logic controllers or PLCs, and the rectifier units that convert AC from the grid into DC needed for electrolysis. 2. The gas generation room, split into two compartments. One for the electrolyzer stacks and the oxygen separation equipment, and another for general processing equipment like pumps, compressors, and water purification units. 3. The gas handling section, where the hydrogen is cleaned, dried, and prepared for use or storage. Now, the magic really happens inside the electrolyzer stacks. At the heart of PEM electrolysis is a solid polymer membrane. This membrane allows protons, positively charged hydrogen ions, to pass through while keeping the hydrogen and oxygen gases separated safely. Here's how it works. At the anode, water molecules split into oxygen gas, protons, and electrons. The protons travel through the membrane to the cathode. At the cathode, these protons combine with electrons to form pure hydrogen gas. Meanwhile, the oxygen, along with water, is carried away to a separation tank where oxygen is safely vented into the atmosphere. The stacks usually require 50 to 55 kilowatt-hours per kilogram of hydrogen. Referred in the literature is usually based on theoretical calculations and is the ideal number, but practically this number could be different as there are so many variables that influence the production efficiency in the real world, like balance of plant, utility power, stack catalyst degradation, plant downtime, thermal protection, etc. The actual production efficiency could be anywhere between 60 to 70 kilowatt-hour kilogram depending on the age of the plant. Now, the hydrogen gas at this stage is still wet, saturated with water vapor, and needs further purification. The hydrogen flows through a pressurized hydrogen-water separator, which removes most of the water. Next comes a critical step. Deoxygenation. Any traces of oxygen left in the hydrogen are removed using a catalyst. This ensures the hydrogen is safe and pure. Drying. Then, the hydrogen passes through desiccant dryers to remove any remaining moisture. Once purified, the hydrogen is stored temporarily in a buffer tank. From there, it can either be compressed further for storage, piped directly to downstream users, or sent to a refueling station. All of this is monitored and controlled automatically, ensuring maximum safety and efficiency. You might wonder, what about the water used in this process? The system needs ultra-pure water for efficient electrolysis. So before entering the electrolyzer, the incoming water undergoes filtration and deionization. Throughout the process, the water levels are monitored in real time. Solenoid valves automatically top up the system whenever needed. A cooler and particle filters ensure that the water maintains the right conditions before being electrolyzed. This smart management ensures that the electrolyzer stacks perform at peak efficiency and last longer. Now let's talk about why proton exchange technology is attracting so much attention. First, high efficiency. PEM electrolyzers respond quickly to fluctuations in renewable energy generation, making them perfect for wind and solar applications. Second, compact and modular design. Because of their structure, PEM units can be scaled up or down easily, from small industrial installations to large-scale hydrogen plants. Third, high-purity hydrogen. Thanks to the solid polymer membrane, the hydrogen produced is extremely pure 99.999%, making it ideal for sensitive applications like fuel cells, chemical manufacturing, and even aviation. In short, proton exchange membrane technology offers a mature, reliable, and future-proof solution for green hydrogen production. Proton exchange membrane electrolyzers are not just pieces of equipment. They are the cornerstones of a new energy era. They allow us to store renewable energy as clean, versatile hydrogen. They provide industries, transport, and even homes with a pathway away from fossil fuels. And they are going to help us build a sustainable, resilient, and clean energy future. As we move forward, green hydrogen, powered by innovations like PEM electrolysis, will be critical in tackling climate change and securing energy independence for countries around the world. Thank you very much for your time and watching my video. Really appreciate you sticking around until the end. If you found this video helpful, please share it with your friends and give it a big thumbs up. And don't forget to hit that subscribe button so you never miss future videos like this. Got a question or a topic you'd love me to cover? Drop a comment below, I'm always excited to hear from you.